Hi everyone, my name is Alex Parmentier. I am a student at the Sheraton School of Computer Science at the University of Waterloo, and I'll be presenting today the work I did with my supervisor Cohen called Personalized Multi-Faceted Trust Modeling in Social Networks. So I'll describe trust modeling, but first I'll say one thing about trust, and that is that it's subjective. We don't expect there to be an objective accounting of who is trustworthy and who's not. In fact, we know that individuals form trusting relationships for personal and subjective reasons. So trust modeling is a procedure applied in multi-agent systems for predicting which agents are trustworthy, particularly is this agent trustworthy for that other agent. And trust models can be useful for social networks when you consider these networks as multi-agent systems, as they can be used to enhance all kinds of recommendations. You can recommend messages, friends, content, things like that. This, of course, has applications for all sorts of things we'd like to do in social networks, like deal with misinformation and filter out antisocial behavior. These are all under the purview of enhancing recommender systems, or they can be considered that way. And so, of course, as this concept is subjective, it follows that personalized trust models are useful for modeling the individual behavior of agents with respect to trust and should be able to increase accuracy in this task. The high-level approach we take in this presentation is we try to predict trustworthy agents in a social network using a data-driven approach, and we evaluate the effect of increased personalization of our models on an item recommendation task down the line based on a data set of Yelp users. Quickly, I'll say that Yelp is a business review site with social features, so in addition to the features you'd expect from a social network, such as agents being able to form friendships and message each other, the users also publish and read reviews for businesses and services. So if you are thinking of visiting a local pizza restaurant, you can go on Yelp and see what other people think about it, and then after you go, you can go and leave your own review and chat with some people about it. We also in this work examine the effect of predicting different types of trust-like features. So multifaceted trust modeling is the machine learning trust model we're using, and this is based on learning the association between vectors of attributes defined over pairs of agents and the status of trust between those agents. The assumption, of course, is that the existence of trustworthiness between agents can be predicted based on the attributes and behaviors of the agents. And then after training, you can predict new statistically likely trustworthy connections by recommending to these agents agents who are predicted to be trustworthy for them. So for every pair of agents, a vector of trust indicators, psi, is defined, and this is based on various comparisons between their attributes and behaviors, and this is shown in equation 1. After these are defined, you can use some sort of classifier or regression in order to model the association between these vectors and some binary or real label representing trust between agents. In Fang et al. 2015, they used a logistic regression to solve this problem. In Morrow et al. 2019, they simply use a weighted average and show that even this can enhance trust modeling. What's nice about this model is that it's really flexible and it's open to extension, as these trust indicators can be tuned to various different domains. Here we have some examples of them. We combined indicators proposed by Fang and Morrow and developed a few novel ones of our own, resulting in a total of 18. For example, here in equation 3, you see that one indicator of potential trustworthiness is the Pearson correlation coefficient between the previous reviewing behavior of the two agents. In equation 4, you can see another potential indicator is the Jacquard similarity in the sets of friends the two agents have. And finally, in equation 5, this one was proposed by Morrow, the ratio of appreciations that one agent has received relative to how much content they're producing could be a potential indicator. So this essentially gives you an idea of relative to how many messages they're producing, how many likes and thumbs up and kudos do they receive. In order to personalize this system, here's the approach we took. Of course, I mentioned that the function from trust indicators to trust can be modeled by any off-the-shelf machine learning method. However, this would generally result in a single function being fit to the entire population of agents. Now, I've mentioned that trust is subjective, so couldn't we instead learn multiple functions, some arbitrary number of functions, in order to more closely fit the subjective preferences of agents? And that's the path that we follow in this particular project. We cluster the agents into k groups of similar agents, and then learn k trust prediction functions based on the content of those clusters. Now, while this does not model each individual agent's behavior, it does hopefully capture the behavior of a group of very similar agents, and what we'd like to evaluate is whether or not that is a useful step towards personalization. The procedure overview. In step 1, we cluster agents based on implicit signals of similarity, namely the similarity of their previous reviewing behavior and the overlap in their friend connections. I've already shown you both of these equations, the PCC and the Jacquard similarity on social connections. We use these same functions as distance measures in order to do the clustering. After the clustering is done, we fit a logistic regression MFTM trust model to each cluster of agents and use these models to predict two types of labels, two types of trust-associated attributes. The first is whether the two agents are friends or not, and this is relevant because users on Yelp use the friend relationship to curate a set of users whose reviews they trust, and the second was the presence of a positive PCC between the agents. This is relevant, of course, because in the context of recommending items to each other, agents who have previously had similar preferences are potentially trustworthy for each other in the future. We use these predicted links to enhance a trust-aware recommender system, in this case TrustMF, which was proposed by Yang et al. In 2013, and we evaluate the accuracy of item recommendations on a test set of review items. In this graph, we show the error as the social regulation hyperparameter is tuned. So on the x-axis, we see basically how important the trust links are considered in terms of the recommendation process. And on the y-axis, we have various metrics capturing the error in our recommendations. And two things worth pointing out here. The first is that the blue and orange lines, which correspond to predicting trustworthiness, can actually find lower errors at correct social regulation settings. And this is lower relative to actually using the explicit trust links in the dataset, which corresponds to the green dotted line. And second, the best performing task was the blue line, which corresponds to clustering agents first and then trying to predict future preference alignment based on the clusters. So in this table, we have the results illustrated again. Once again, at the top, real friends is the worst predicting task, and this is when the actual friendship relations from the dataset are used to try to enhance item recommendation. All of the prediction-based tasks, whether we're trying to predict friendship links or positive correlation in future behavior, perform better than this. And our best performing task was when we clustered users based on previous similar preferences and tried to predict future positive similar preferences. The conclusions of this work, we showed that a simple clustering approach to personalizing trust modeling can improve performance in a downstream item recommendation task where trust is considered as part of the recommendation task. And this is evidence for the importance of considering trust as subjective and striving for more personalized solutions. It's also further evidence of the usefulness of trust modeling to recommendation in social networks, as just as Fang and Morrow showed, predicting trust links via multifaceted trust modeling outperforms using the explicit trust links available in the dataset. And I'll just briefly mention that we have more experiments underway with new prediction methods and more datasets in order to further investigate this problem. Thank you. That's the end of the presentation. I'm told that there will be a chat room available for questions, and I'll be looking at that. Otherwise, please feel free to email me if there's anything else you'd like to know. So thanks once again. I hope you enjoyed the presentation, and stay safe.